Welcome back to IM1, everybody. Today's topic 5.21. This would be part 3, day 2 of the lesson, pretty much. So we're going to start off again where we left off yesterday, where we were talking about how the sequences, right? So we created a table yesterday. We had the arithmetic and the geometric sequences. So these were the arithmetic, right, and the geometric sequences. So again, from yesterday, what we discussed is pretty much that the arithmetic sequences change by addition or subtraction, and the geometric sequences change by multiplication or division. So what we're going to do first, we're going to graph the arithmetic sequences right here. So the arithmetic. And again, n is pretty much the same as our x, or these is our n axis. And then this would be our t of n axis. All right. So again, first value here, if you guys notice on the table. So we have 1, -4. So 1 and -4 down here. And then our next value is 1, -2, -1. And then again, I keep going up by 3 each time. So these are the points that were generated by that sequence, right? And again, it can continue on and on. And then for the second one, we're going to be looking at pretty much starting off, our initial value is 1, 9 there. So 1, 9. It's not on if you notice, this one's not on the y-axis, but this is 1, 9. And then from there, we're going to be going to 2, 7. So we're decreasing. We're going down by 2 each time. And then let's plot our geometric sequences. So our geometric sequence starts off at 1, 1.5. So 1, 1.5 would be right there. The next one is 2, 3. And then 3, 6. And then 4, 12. 5, 24. And that's pretty much the last point I can plot. And then on the last one, we had one that was dividing, right? So this one was multiplying by 2. This one is dividing by 3. So we start off at 27. So 1, 27 would be somewhere up here. And then from there, we go to 2, 9. So that's a quick drop. 2, 9 right there. And then our next value is 3, 3. And then we have 4, 1. And then it starts getting smaller and smaller and smaller, getting closer and closer pretty much to the x-axis. All right, so let's look at the next question. It says, describe the differences between the growth of the values of the sequences C and D. Actually, we're going to be talking about not C and D here, but the two sequences we're going to be talking about is A and F and B and H. So A and F, A and F, and the other one too are going to be B and H. So the pattern between sequences C and D, so again, that pattern grows, or not C and D, sorry. We're talking about A and F, right? The pattern grows by addition or subtraction. And then the pattern for between sequences B and H, all right, so B and H, those grow by, so the pattern grows by multiplication or division. And then it says describe the difference between the shape of the graphs and sequences. Again, we have sequences A and F and sequences B and H. And then the shape of this. So again, for the first two, for the arithmetic sequence, if you guys notice, again, it's a linear shape, right? It's a straight line. So both graphs are straight lines or follow a straight line pattern, right? And then for B and H, right? So for B and H, so the shape of those graphs, if you guys notice here, it's like a kind of like go straight, and then up. And then this one started up here and then again, right? So it kind of like starts at a high value or a low value and it starts to increase rapidly, right? So it kind of looks like a slide, if you guys want to call it that. So the shape, so follow a, so these were follow a curving pattern, right? A curved pattern. All right, so question 544. Some types of sequences have special names. So again, when the sequence generator adds a constant to each previous term, it's called the arithmetic sequence. Again, we've been talking about those, right? So this is just to give you guys a refresher. Which of the following sequences from problem 542 fall into this family? Should you include the sequence labeled F in this family? Why or why not? So again, we already talked about this, so we know that A, B, I'm sorry, it wasn't B. So it's A, D, and F. A, D, and F, right? A, D, and F. And then we should include F in this family because, again, F is included because it's adding a negative, right? Because it still follows a linear pattern. And then when the sequence generator multiplies a constant with each previous term, we call that the geometric sequence. So again, we already talked about this. The ones that were geometric were patterns pretty much B, C, G, H, and J. B, C, G, H, and J. B, C, G, H, and J. And then it says, should H be in this group? Why or why not? H was a pattern that was being divided by 3, right? So again, same thing, right? Both of them follow a curve pattern, right? An exponential pattern, right? So yes, H should also be included. And then to conclude our lesson, we have the exit ticket right here. So for each of the following, describe the pattern is growing and stay whether the sequence is arithmetic, geometric, then list the next 3 terms in the pattern. So here we have 3, 5, 7, and 9. So the growth here is plus 2, right? We're adding 2 each time. The type of sequence it is, this would be an arithmetic sequence. And then the next 3 terms, so if I add 2 to that, I'm going to get 11. I add 2 to that, I'm going to get 13. And then finally 15. And then for B down here, we have 2, 6, 18, 54. So the growth here is by multiplying by 3. So therefore, the type of sequence this is a geometric sequence, right? The one that grows by multiplying. And the next 3 terms, if I multiply 3 times 54, I get 150, 162. 3 times 162 would be 486. And then 3 times 486 would be 1458. For C, we have 96, 48, 24, and 12. So here the growth pattern, since it is going down, right? Remember, if you see a pattern that's going down, it's going to be either dividing or subtracting. Here it goes down by big chunks, so it's going to be dividing. And then 96 and 48, if you divide those two, you get 2. 48 divided by 24, you get 2. 24 divided by 12, you also get 2. So therefore, we're dividing by 2 each time. The type of sequence, this is also a geometric sequence because, again, right? Both multiplication and division are inverses of each other. That's why they're geometric sequences. In the next three terms, if I divide 12 by 2, I'm going to get 6. Divide this by 2, you get 3. And then divide that by 2, you get 3 over 2. And then the last pattern, we have 17, 13, 9, and 5. So here, what we're going to do is, again, finish it off with the growth. It goes down, and it seems to be going down by 4, so minus 4 each time. So therefore, this is an arithmetic sequence. And then the next three terms, if you go down by 4, you're going to have positive 1, subtract 4, negative 3, subtract 4, you get negative 7.